All right, let's talk about electronic structure. Okay, elements are determined by atomic numbers. Okay, atomic numbers equal proton numbers and electron numbers of of each atom of a given element. Chemical properties are determined by the number of electrons of an element. Uh, Electrons do not move around freely. They are confined in a specific area corresponding to the energy level. All right. Electron energy is quantized. Electrons occupy spaces based on energy levels. Okay, electron occupied spaces are called shells. Shells. Okay, the distance of the shells to the nucleus correspond to the electron energy. The closer a shell is to its nucleus, the weaker energy of the electrons. The farther the shell to the nucleus, the stronger the energy, stronger energy the electrons have. Okay, you can take a look at this cartoon. The nucleus here, and the first shell, and the second shell, and the third shell. The dots represents the electrons. Okay, the first shell has the lowest energy level. Second shell electron. Some second shells higher than the first one, and the electrons of third shells have a higher energy than the electron on the second shell. Okay. Okay. The volume also different. The volume of the shell also different. The farther the shell is from the nucleus, the larger the volume of the shell. Okay, and the more electrons it can hold. Okay, the maximum number of electrons, okay, is given by the form 2n squared. Okay, the n is the shell number. Okay, you can take a look at the relationship between shell level and the electron numbers, maximum electron numbers here. Okay, the first shell, 2 electrons. Okay, this is the maximum electrons. Okay, the second one, 8, third one, 18, and fourth one is 32. They follow this formula. Okay, you can calculate how many maximum electrons if you know the shell number. All right. Okay. Next, let's take a look at the subshells. The shells are divided further into subshells. This including S, P, D, F subshells. Okay, the energy level of subshells is this: S lower than P, P lower than D, D lower than F. The number of shells, subshells, in a given shell equals the number of the shell number. That means if the first shell has only one subshell, the second shell has 2 subshells, and third shell has 3 subshells. Okay. The subshells can be further divided into orbitals. Okay, orbitals. Each orbital can hold maximum 2 electrons. It's called electron pairs, 2 electrons. Okay, each type of subshells contain a specific number of orbitals. Each type of subshells contain a specific number of orbitals. You can take a look at it, this relationship on this table. Okay, S subshell, P subshell, D subshell, F subshell, and orbital number of each subshell is 1, 3, 5, 7, and the maximum maximum electrons of each subshells 2, 6, 10, 14. All right, let's take a look at the summary of the electronic structure. Okay. Okay, this is the table summarizes the electronic structure, and this is on the left side. This column is the shell, and this is subshells. And the first shell has only one subshell S. The second shell has 2 subshells SP. Actually, this is the small s, small p. Okay, small p, small s, d. Okay, third shell has a SP and the D subshells. Fourth shell the SPDF, and then you can see the orbitals. Okay, the first shell, the S subshell has only one orbital, and S has 1, 2s, 2s, 1 orbital, and the P has 3 orbitals. On the third shell, you can see 1 orbital on the S subshell, 3 orbitals on the P subshell, and 5 orbitals on the D subshells. Okay, and the fourth shells. Okay, and this 1s orbitals, 3 p orbitals, 5 d orbitals, and 7 f orbitals. Okay, then from this you can calculate the maximum number of electrons. Okay, S only has 1 orbital. It has 2 maximum electrons. Okay, for the second shell, they had 1 S, 3 P. Total is 8. 2 plus 6, and this one has 18. 2 plus 6 plus 10, and this one has 32. 2 plus 6 plus 10 plus 14, and the maximum electron for fourth shell is 32 electrons. All right, that's the electronic structure of an atom.